Hello students, Miss Slyman here, and I'm recording this using my headphone microphone at the airport, and I don't have my pen to write with, so this is going to be a little bit of a crazy video. We'll see how it goes. Okay, so really what I want to show you is a way of thinking algebraically with symbols and with tiles, and we'll look at this more on the board because really what I want to show you, there's a lot of web-based stuff, but unfortunately it doesn't work on the iPad because the iPad doesn't support Flash-based stuff. But the idea of an algebra tile is that we can use tiles, like actual plastic squares, rectangles, to represent unknowns. So we start with this idea of the constant. Remember, the constant has no variable. So our constant is just a 1 by 1 square. And using algebra, we call it 1. A linear factor has some length that we don't know. So since we don't know it, we call it x. It has a width of 1. It has the same width as this square over here. And the area of this is 1 times x, which is x. We could also think of this as being 1x. Sorry, again, using my finger. A quadratic tile is a square, and this time it has a length of x and a width of x, so its area is x squared, or 1x squared. On paper, when I'm talking about negative values, quite often I leave them blank. If you're talking about, if we're working with actual tiles or working in color, then they would be red as the negative. So in algebraic form, I've got 1x, and I've got 3 1s. So altogether, this is x plus 3. Over here, now I have 2 x's, and then I have 4 negative 1s. So together, that's 2x minus 4. Now I have 1x squared, I have 3 negative x's, and I have 2 constant terms. This one is negative 1x squared, positive 2x, negative 2, and positive 3. But of course I want to collect my like terms. So I have negative 1x squared plus 2x plus 3. Ooh, sorry. Negative 2 plus 3 is plus 1. So now looking at this tile, the algebraic expression it represents is 1x squared, and then I have 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6 of the 1s. So 6 times 1 is 6. An expression that represents the length of the sides, well, if I look at this side has a length of x and 3 1s. So the length of one side is x plus 3. The length of this other side, that length is x, this length is 2. So the second side is x plus 2. How can the diagram also represent x plus 3 times x plus 2? Well, x plus 3 times x plus 2 is the same as the length times the width. So it can also represent that multiplication with its area. And the area was my 1x squared plus 5x plus 6. So that means that x plus 3 times x plus 2 is equal to x squared plus 5x plus 6. So if you go to this link, which I can't go to because I'm on my iPad, but if you go to this link, at the bottom there's something that says like create your own or insert your own, something like that. We can look at it in class. But really what you can do is you can set up a multiplication yourself. So if I think about multiplying this, then I've got on one side 1x and 5 1s. So here's 1x, and then I have 5. 3. I'm going to actually use this side as my x plus 3 because I don't have room for all 5. And now on this side I can do x plus 5, 2, 3, 4, 5. And now I'm going to fill in the area because this is a length times width. So I want to fill in this total area here, represented by my length times width. Well, I know that this part of my area is x times x, so this part is an x squared. This part of my area has my x times my 3, so this part of the area can be filled in by 3 x's. So 1x, 2x, 3 x's. This part of my area here can be filled in with 5 x's. Sorry that my drawing is not so good here today. So I have another 5 x's here. And now all of this area is filled in by all of these multiplications of 1 times 1. That's that area here. Or 1 times another 1. That's that area here. So this gets filled in, preferably with straight lines. Sorry, this one, well, this x bit is a little bit too narrow or too wide. Let's see if we can make it a little bit better. This part shouldn't be so wide here. All right, so goodness, it's terrible drawing here. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my total area, which is given by my length times my width, my total area, so length times width, gave a total area of x squared plus 8x, because I have to add up 5 x's here and 5 x's here. Sorry, 5 x's here and 3 here makes 8. And then all my 1's, there's 15 of those 1's. So this is how I can think of it visually. The other way I can think of it is using this term FOIL. So FOIL says first, outside, inside, last. Well, first is when I multiply x times x. So x times x is x squared. Outside, so that was my first. Outside is when I multiply x times 3. That's 3x. Inside is when I multiply the numbers on the inside. 5 times x. Last is when I multiply my last two numbers, the 5 and the 3. And notice if I collect my like terms, I have to put those together and I end up back with that same result. So we can use FOIL or we can use the visual method. So I'm going to show you this first one. X times x is x squared. X squared. X times 8 is 8x. 2 times x is 2x. 8 times 2 is 16. Collect like terms. X squared plus 10x plus 16. X times x is x squared. X times 4 is positive 4x. Negative 1 times x, negative 1x. Negative 1 times 4, negative 4. Collect like terms. X squared plus 3x minus 4. All right, next one. 2x times x is 2x squared. 2x times negative 5, negative 10x. 1 times x is 1x. 1 times negative 5 is negative 5. Collect like terms. 2x squared minus 9x minus 5. X times 2x, 2x squared. X times negative 5, negative 5x. Negative 4 times 2, negative 8x. Negative 4 times negative 5, positive 20. Collect like terms. 2x squared minus 13x, positive 20. Okay, go ahead and complete the rest of example 3 on your own. And then when we get in class on Monday, we can talk about that. Okay, so looking at this last diagram, this is a visual diagram. The product that it represents, and I should have really shaded these all in. Well, actually, we could shade them in because this represents a positive x squared. This represents 5x, positive 5x, positive 2x, positive 10. So what this is really showing us is that x plus 2 times x plus 5 is equal to x squared plus 7x plus 10. And let me go back and actually fill in these areas instead. So x times x is x squared. 2 times x is 2x. That's a squared. Oh my goodness. I really should use my pen, not my finger. X squared. 5 times x. Length of 5, width of x. 5x. Length of 5, width of 2 is 10. So always I'm filling in the area. So length x, width x makes an area x squared. Okay, crazy video from the airport. There you go. I'll see you guys on Monday.